Hello student, I am Tanmay Mujumdar. Today I am going to discuss the different type of data in research methodology. Basically, there are two types of data. One is qualitative, another is quantitative data. Qualitative data is further classified as a nominal data and ordinal data. And quantitative data is broadly classified as discrete data, continuous data, interval data, and ratio data. Now, in the next slide, I am going to discuss in details what is qualitative data and what is quantitative data. Qualitative data is descriptive and it triggers phenomena which can be observed but not measured, such as occupation, taste, different texture, feel, gender, nationality, and appearance. On the other hand, quantitative data measured number. It focuses on numbers and mathematical calculations is possible. For example, the height, weight, volume, length, size, humidity, speed, age, etc. Now, in research, quantitative and qualitative data provide the different outcomes and are often used together to get a full picture of the populations. For example, if data are collected on annual income, annual income is actually the quantitative data, and occupation is actually qualitative data. Both could also be gathered to get more detail on the average annual income for each type of occupations. Now, on the next slide, I am going to discuss the different type of qualitative data. Nominal data. Nominal data, also known as nominal scale, it is a type of data that is used to label variable without providing any quantitative value. For example, gender like male, female, nationality, religion, hair color. In this regard, I just give one example. Suppose the assignment of number of football players in order to identify them. In this case, such numbers cannot be considered to be associated with an order scale for their order is of no consequences. The numbers is just convenient label for the particular class of events and as such have no quantitative value. So, we can understand from here the nominal scales only provide convenient ways of keeping track of people, objects and events. So from here we can understand nominal scales is the least powerful level of measurement. The counting of number in each group is the only possible arithmetic operations when a nominal scales is employed. We never apply the mode or measure of central tendency as well as the measure of dispersions for nominal scales. Only chi-square test is the most common test of the statistical significance that can be utilized, and for the measures of correlations and the contingency coefficient can be worked out. So from here we can understand a nominal scale simply describe the differences between things by assigning them to categories. So nominal data are thus only counted data. Clear? Ordinal data. Ordinal data is actually the categorical data where the variables have natural ordered categories and the distance between the categories is not known. Such, for example, low, medium, high, or satisfied, dissatisfied, extremely satisfied. So rank orders is only possible by the ordinal data. Rank orders represents ordinal scales and are frequently used in research relating to the qualitative phenomena. In this regard, I just give one example. Suppose a student's rank is his graduation's class involves the use of an ordinal scales. So one has to be very careful in making statement about the scores based on the ordinal scales. For instance, suppose if Ram's position in his class is 10 and Mohan positions is 40, it cannot be said that Ram positions is 4 times as good as the Mohan. So the statement would make no sense at all. So from that we can understand Ordinal scales only permit the ranking of items from highest to lowest, but the real difference between the two adjacent rank is not possible. So, the use of an ordinal scales implies a statement of greater than or less than or equal. But how much greater or less is not determined by the ordinal scales. Since the numbers of the scales have only a rank meaning, so we can apply only median, percentile or quartile in the ordinal scales. Now in the next slide I am going to discuss different type of quantitative data. Discrete data. Discrete data can only take certain or finite value. For example, family size means the number of the members of family. It may be either 1 or 2 or 3 or 4, etc. We cannot speak of 2.73 members in a family. Such a way, days of the month, number of students in a class, etc. On the other hand, continuous data can take any value within a range, even fractions. For example, height, weight, temperature, time, etc. Clear? In other way, continuous data is termed as a group data and discrete data is termed as a ungrouped data. Now, on the next slide, I am going to discuss interval data and ratio data. Interval data. It is also called as interval scale. It is a type of data which is measured along a scale in which each point is placed at an equal distance from one another. For example, 20 degrees centigrade is warmer than 10 and the difference between 20 degree and 10 degrees is 10 degrees. The primary limitations of the interval scale is the lack of true zero. It means interval scales can have an arbitrary zero, but it is not possible to determine for them what may be called an absolute zero or the unique origin. In this regard, we can say that the increase in temperature from 30 degree to 40 degree involves the same increase in temperature as an increase from 60 degree to 70 degree. But one cannot say that the temperature of 60 degree is twice as warm as the temperature of 30 degree because both numbers are dependent on the fact that the zero on the scale is set arbitrarily at the temperature of the freezing point of water. The ratio of the two temperature 30 degree and 60 degree means nothing because 0 is an arbitrary point. But interval scales provide more powerful measurement than ordinal scales. For interval scales, we can apply standard deviation, mean, Pearson's product moment correlation coefficient techniques, as well as t-test and f-test. Next is ratio data. Ratio data is defined as a quantitative data having the same properties as interval data with an equal and definitive ratio between each data and absolute zero being treated as a point of origin. In other words, there can be no negative numerical value in ratio data. For example, height. Negative height is not possible in real life. In other hand, the 0 point on a centimeter scales indicates the complete absence of length or height. So, ratio scales have an absolute or true zero of measurement, it can say, but in turn, absolute zero is not as precise as it was once believed to be. Now, ratio scales represents the actual amount of variables such as weight, height, distance, etc. Multiplications and divisions can be used with these scales, but not with other scales mentioned above. Geometric and harmonic means can be used as measures of central tendency, and coefficient of variations may also be calculated. Now, from the above discussions, we can say ratio scales or ratio data is the most precise types of scales or data, and the nominal scales or the nominal data is the least precise types of scales or data. Researchers in physical sciences have the advantage to describe variables in ratio scales form, but the behavioral sciences are generally limited to describe variables in interval scales form. Finally, I draw the conclusion that ordinal data and nominal data both are qualitative data. Nominal data is representing the name and ordinal data is representing the order or rank or scaling. On the other hand, interval data and ratio data both are quantitative data. Interval data represent the differences between measurements but not true zero, and the ratio data represent differences between measurement and true zero or absolute zero is also exist. That's it.